Hi everyone, I'm Tianru Zhang, and today I would like to introduce our work ReStore, a reinforcement learning approach for data migration in multi-tier storage. So I will begin with the introduction of motivations and problem settings. Then I will present the core design of ReStore, and then I will show some key experimental results. And finally, I will conclude the presentation with takeaways. So first, I will talk about the data management challenges in tiered storage. Multi-tier storage systems comes from the fact that nowadays systems usually employ multiple different storage devices, such as SSDs with different interfaces, or HDDs, or other type of storage devices. These devices are very different in terms of the properties such as cost, speed, and capacity. So tiered storage systems organize them in a tiered format so that it serves as one entire secondary storage to interact with the main memory. And in common database management systems, applications usually operate on a very fine-grained level, that is the page level. So the first challenge is the page level data management in tiered storage system. And the second challenge in a tiered storage system is the page migration, because pages cannot be visited on one tier forever because it can be hot or cold throughout different workloads. So migrations between different tiers is essential. So to achieve it, we define a page migration policy to control the page migrations between tiers. And an ideal page migration policy should be first reduce the response time of the system, and then at the same time keep the low latency, limited migration overhead, and adaptiveness to workload shift. So our work ReStore solve this by modeling the data migration problem as a Markov decision process and then solve it using the reinforcement learning. So we define the state variables using the highly relevant factors such as the temperature, which is the representation of the recency and frequency of the page accesses, and also the S2, which is the load pressure of each tier, representing how many tasks is pending on the tier. And then the action upon each migration decision is whether to move or not. So since the overall ultimate objective is to minimize the system latency, so we define the reward as the negative of the estimated response time. So maximizing the reward by reinforcement tuning will lead to a minimized latency. And then we leverage a multi-agent design of the reinforcement learning, as well as using a lightweight fully rule-based function to do the functional approximation of value functions, and then update the parameters of each agent using the temporal difference learning. So together, we design a ReStore as an adaptive and lightweight data migration policy. So we tested ReStore on different scenarios, comparing with other state-of-the-art policies, and our results shows that ReStore can achieve the best runtime by reducing the migrations up to 40 times smaller than the other policies. We have also tested on dynamic workloads, real-world benchmark traces, and cloud-based storage to further demonstrate the ability of ReStore. So to conclude, we present ReStore, a reinforcement tuning-based page-level migration policy for multi-tier storage, which jointly modeling the workload dynamics and internal device properties. So through the experiments, we have shown that ReStore can achieve up to 6 times lower runtime and 50 times fewer migrations. And it is robust across static, dynamic workloads, real cases, real traces, and diverse devices. So our code is also publicly available through this GitHub link, and you are welcome to scan this QR code to follow our future works. Thank you very much.